Welcome to this series of programming in Java. I am Dr. Preeti Jagwani, Department of Computer Science, Aribhat College, University of Delhi. So today we are going to proceed forward with our fundamentals of exception handling, and in our previous lectures we have seen what are the basics of these exception handling, what are the keywords which are going to be used while framing the programs or while creation of these programs in related to exception handling, and we have also seen that why it is necessary or why it is advisable to handle an exception. Now here for example, let us try to sum up with a particular program that whatever programs we have seen here. So here try is a block which is having a statement which may throw an exception, and this try is actually placed inside a method, here the main method, and that try is having a statement which is int data is equals to 50 by 0, that is going to throw an exception which is the arithmetic exception, and then that arithmetic exception is being handled by the catch block which is written just after this try block, and the exception class and the reference variable which is arithmetic exception then E, and whatever is inside that reference variable or inside that object we can say will be printed when we are going to print E, and then we have written rest of the code. So what will happen here? This statement integer data is equals to 50 by 0 is going to raise an exception. That exception will be handled by this catch block, and then rest of the code or rest of the program will continue in a clean manner. So yes, generally we say that whenever we are having our programs made with the help of exception handling, that program is going to have a kind of clean code. Now for example, let us say we are going to place some code inside the try block, but just after the statement which may throw an exception, then what will happen to that particular code, that also we need to see. So here we have integer data is equals to 50 divided by 0, which is going to throw an exception, and if that exception occurs, the remaining statement will not be executed. So within the try block we have one more statement which says rest of the code system.out.println rest of the code. So as the statement above is going to throw an exception, this statement which says rest of the code will not be executed, because on encountering an exception the control will be directly we can say passed on to the catch statement which is written there just after the try. So this will just print the arithmetic exception E, which is exception in thread main java.lang.arithmetic exception, and then that divide by 0. That is not going to print that statement which is called as rest of the code, because try block, if an exception occurs in the try block, the rest of the block code will not be executed. Similarly, for example, in the previous lecture we have also seen that this catch block is going to have either the parent class exception or the particular exception which is going to be raised there. So in the previous program we have seen that the similar exception is being kind of we can say caught by the catch block which is having arithmetic exception as the parameter, and here we have changed the parameter. So we have a try block which says integer data is equals to 50 by 0, exception is being kind of we can say thrown, and that can also be handled by the catch which is having the parent class exception. So exception class is the parent class of all the exceptions. So as the parameter of the catch as the parameter of the catch clause, we either need the exact exception which is being raised, which is arithmetic exception here, or we need a parent class exception. Any one of these two is going to be kind of is okay here, but ultimately it is going to print java.lang.arithmetic exception divide by 0, and then rest of the code will be printed, which is given after the catch block. So, the important thing which I want to underline here is the parameter of the catch block, either the proper exception class or the parent class exception, both are fine. Now, till this point what we have done here is we have printed whatever is inside that exception object. So, for example, we have an arithmetic exception E inside the braces. We have printed whatever contents are stored inside this E, which is the the name of the function which is throwing the exception, then what kind of exception it is, which is basically the name of the exception, and then the description of the exception. Now, is it possible to print a custom message on handling on kind of while handling the exception? So, yes, we can say that is perfectly possible, and it is done here with the help of an example which is being shown on the screen. And here we have try which is again integer data is equals to 50 by 0, which is going to throw an exception, and in order to handle the exception we have used the parent class exception E. But here please notice the thing which is inside written inside the catch block, that is instead of saying system.out.println or print E, that means instead of printing the contents of the exception object, we are printing or we are displaying a custom message here. So, system.out.println cannot divide by 0 or any other custom message whichever is appropriate or whichever you want can be displayed here. So, it is not necessary that whatever is inside this inside that exception object is to be displayed. You can display your custom message also. Then the next question which is being which is being raised here is can we resolve the exception in the catch block? So, for example, we are having something which is let us say a divide by 0 error. Can we have that denominator which is 0 in a variable, and then we can change the value of the variable. So, this is kind of we can say resolving the exception inside the catch block. So, yes, that is also possible. So, here you can see that within the main function we have three variables. One is integer I is equals to 50, then j is equals to 0, and the integer variable data, and then data is that data variable is being assigned value of I divided by j, which is 50 divided by 0 inside the try block, because this is the statement which may throw an exception, and it is being handled by the catch statement, which is having the parent class as the parent class and its reference variable as the parameters, we can say. But instead of writing or along with the writing also we can say writing or printing the statement or printing the contents of that object E or any other custom message which we did in our just previous program. What we have written here is system.out.println I divided by j plus 2. So, that means here we are kind of we can say changing the value of the denominator which was 0, because of which an exception was being raised. So, in a way we are trying to resolve that exception within the catch block, and this is a scenario which is perfectly acceptable. So, here we have seen we are actually looking into the various small questions or various small situations which can come up while handling or while dealing with the exception handling mechanism. Then along with the try block, can we enclose exception code in the catch block also? That means apart from resolving the exception or printing the details of the exception or printing the custom message, is it possible to have a code inside the inside the catch block that may throw an exception. So, yes, this is perfectly possible, and it is how it is going to be done, that is given in the example on the screen. So, here we have try block which says integer data 1 is equals to 50 by 0. In order to handle that exception which is being raised, which is an arithmetic divide by 0 exception, we have a catch block. So, catch exception E is there. Now, what is the twist here? So, the twist here is generating the exception inside the catch block. So, within the catch block we have integer data 2 is equals to 50 by 0, and that 50 by 0 may throw an exception, and then after the catch block we have system.out.println, rest of the code is there. So, what we have done here within the catch block, we have not printed the contents of E object, we have not printed any custom message, or we have not printed any, or we have not given any code to be executed. Instead, we have given a particular code which may throw an exception. So, that is also a perfectly possible scenario, that is along with the try block we can enclose exception code in a catch block also. Then what will happen? So, exception in thread men. So, the output will says exception in thread men java dot lang dot arithmetic exception divide by 0, and the catch block did not contain the exception code. So, enclose the exception code within the try block and use catch block only to handle the exception. It is okay, I mean like syntax wise it is fine to enclose this here, but it is not a sensible idea, or it makes no sense no sense to give the exception or give the code which is going to throw an exception inside the catch block. So, enclose the exception code within a try block and use the catch block only to handle the exception. So, the catch block should not contain the did not contain the exception code. So, here is we can say one more flavor of this a small program of try and catch handling thing which we have seen. Now, let us proceed with one more example to handle the checked exception. So, in order to handle the checked exception, and what is actually a checked exception, that we have already seen in our previous lectures. Here we are going to throw here we are going to use a code which may throw an exception, and that is actually a checked exception. So, with the checked exceptions, the situation is thus that compiler will not allow you to compile the program unless you handle that properly well in advance. So, here we have import java.io.file not found exception. That means we are particularly importing that particular class which is file not found exception. Then we have import java.io.printWriter. This print writer is actually required to write something through this print writer, and we have within the main function we have a main function as public static void main, and we have an reference variable pw of this print writer, and within this try block, which is the code which may throw an exception, is actually pw is equals to new print writer and some text file path is given inside this. So, that code may throw an exception, and then we can write a line on the printer for which we are going to use this print writer class, and the corresponding reference variable is which is saved. And we are aware that this is going to throw an exception. So, that exception has to be handled, and in order to provide the exception handler for that checked exception, we can either use the keyword throws, or we can use the catch block as as we have done with the other programs. So, catch is within the catch we have file not found exception E, and that contents of E is being printed, and then we have write something on the screen. So that's it, system.out.println is going to write that on the screen, and when we say pw.println, that is going to write something onto the kind of printer stream, we can say. So here system.out.println file saved successfully, that is going to be written. So here we have handled with a, or we have dealt with a checked exception, and that checked exception is being handled with the help of a catch clause. Now please remember our previous lectures in which we have dealt with the similar situation of checked exceptions, but at that time we have handled those checked exception using the keyword, using a different keyword which is throw, and we have not used the catch exception handler there. So here we have given you a kind of we can say a different idea of handling the checked exception, we can say. Now in our previous lecture we have also I have also told you that along with the try block there can be multiple catch blocks, that is a try block can be followed by one or more catch blocks. And each catch block must contain a different exception handler. So, one catch block may have arithmetic exception handler, another one may have file not found, then the third one may have null pointer exception, and then so on and so forth. So, each catch block must contain a different exception handler. And these different catch blocks are there to perform the different task at the occurrence of different exceptions, and this can be done with the help of multi catch blocks. So, for example, we have a code which may raise an exception which is divide by 0, which may raise a null pointer exception, or which may raise an exception which is array index out of bounds. So, in order to handle all these exception in a single program, we can have different or multiple catch blocks. But please remember that at one point of time only one exception is going to occur, because the moment exception is going to occur, the control will be directly transferred to the catch block. It will not go into the further details written inside the try block, and it will not have any chance to raise another exception. So, at a time only one exception occurs, and because of this reason, as a consequence, we can say at a time only one catch block will be executed. Now let us say we have arithmetic exceptions, we have array index out of bounds, we have null pointer exception, and also we have a parent class exception. So, there is a specific order of placing these catch blocks. That means all catch blocks must be ordered from most specific to most general. That is, the catch for the arithmetic exception must come before the catch for the parent class exception, or even the catch for the null pointer exception, or even the catch for the array index out of bound exception must come before the catch for the parent class exception. So, here we try to understood the we are trying to understand the multi catch block in Java with the help of an figure. So, here these early statement says execute try block, and if there is no exception, then we are going to execute the statement which are out of that try catch block. But if there is an exception, then the system has to find the appropriate catch block. So, that means there can be one catch block about one particular type, let us say arithmetic exception, another catch block could be array index out of bound, third catch block could be null pointer exception, and finally we can have one parent exception class also. So, it is the responsibility of the system to look for the particular or look for the appropriate we can say catch block. So, either the exception catch block 1 will be executed, or the catch block 2, or the catch block 3 will be executed, and then finally your code is going to exit in a clean manner after executing the statements that are out of try and catch block. So, let us see this with the help of an example, and here we have with inside the try block we have two statements. One is the declaration of an array which says A is an integer type array, and that is an integer type array of 5 integers, and which is being we can say declared with the help of the statement integer A, array symbol is equals to new int 5, and then A5 is equals to 30 divided by 0. Now, here two things are happening. One is an array which is being created for the total size of the array obviously is 5, but what is the index? Index goes from 0 to 4. And now, on the very next statement we are trying to write A of 5 is equals to 30 by 0. Now, two things are happening in this statement. One is the 30 by 0 thing, which is obviously going to raise an exception of divide by 0 arithmetic exception, and another one is to referring the index A of 5 which is not there. So, here we have written multiple catch statements. One is the arithmetic exception E, and along with this please notice that program is not being program is not complete here. Another is the array index out of bound exception, and then the corresponding body of the catch block, and finally we have the parent class exception E also, which says parent exception occurs, and then finally the rest of the code. Now, the question here is which particular exception is going to be raised. Now, we need to look into the statement which is kind of raising an exception. So, the statement is A of 5 is equals to 30 by 0, and in the initial stages of any programming languages we always study that whatever is being written on the right hand side of the is equals to operator, which is the initialization operator, that right hand side is evaluated first, and then the result of the right hand side will be kind of stored inside whatever variable you have on the left hand side. So, in order to evaluate the right hand side of the is equals to operator, the system is going to encounter 30 by 0, and immediately it is going to throw an exception which is the arithmetic exception. It is not going to get a chance of getting into A of 5 and looking into whether the index is out of bounds or not. So, here the first exception which is being raised as per the kind of evaluation rules is the arithmetic exception, and that is going to be raised when the system is going to calculate 30 by 0. So, arithmetic exception is being raised, and accordingly the answer is printed. Arithmetic exception whatever is being written inside that catch block which is arithmetic exception occurs, and then rest of the code will be executed. The system is not going to have a chance of getting into array index out of bound exception or getting into the parent class exception, because this is certain that only one catch block can be kind of we can say executed. Now, in the next thing we can see that how this array index out of bounds is going to be printed. So, here we have twisted or we have tweaked a little bit of a try block in this next statement which was throwing an exception which was in A of 5 is equals to 30 divided by 0. Instead of that statement we have written system.out.println A of 10. So, now A of 10 here is actually not existing, and here system is not going to raise any arithmetic exception because there is no such scenario. Only the exception which is related to the array index out of bounds will be kind of printed, and then finally the rest of the code will be printed. So, the appropriate exception if there is going to be caught by the system and then handled accordingly. Now what will happen, if we have, if we do not have any appropriate exception. So, for example, the code which we have seen is, kind of raising an exception of null pointer exception, and we have not given null pointer exception. Instead, we have given, the class exception, the parent class exception E. So, in case of absence of the proper or the particular exception class, the parent class exception is going to be thrown. Now, let us see one more example of multiple catch block. In this catch block, we have integer a is equals to new int 5. Within the try block, we have this. A of 5 is equals to 30 by 0 and system dot out dot println a of 10. And we have, both the exceptions here. One is the arithmetic exception, then we have array index out of bounds exception, which is, again followed by the parent class exception and the rest of the code. Now, in order to look into this code, we need that the first the output which is going to be there will be the arithmetic exception, because that is the line which is presiding, the line which is throwing the array index out of bound exception. So, the moment one exception is kind of raised, the system is not going to go into the rest of the code which is written inside the try block. Now, let us say, for example, we have one try thing which is generating null pointer exception as shown on the screen. String s is equals to null, and system dot out dot println we have printed the length of a null pointer. And within the catch block, we are writing arithmetic exception, array index out of bounds exception, and the parent class exception. So, that means null pointer exception is not being given there. So, the proper exception is not there. So, in that situation, the catch block containing the parent exception class, which is the exception class with the capital E, will be invoked. So, here in this lecture, we have tried to understood what are the different flavors of program under the umbrella of various mechanism in order to handle the exception. So, we have seen multiple catch blocks, then which particular exception or which particular catch block is going to be is going to handle the is going to handle the exception. And here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this lecture. I will see you in the next one. Till then, take care. Goodbye.